Hey everybody, it's Leah. Today I'll be making a video on dosage and solutions for nursing school. If you haven't subscribed yet, please subscribe, I'd really appreciate it. So let's go ahead and get started. Okay, so the dosage and solutions exam is usually the first exam you have in nursing school. In our school we had 3 attempts and we had to make 100 in order to pass. Otherwise we'd be dropped from the class and a second class that was linked to it. Most schools require just 90%. Okay, so we'll start with some abbreviations you have to know in order to understand the question. So the first one is PRN. This means as needed. Stat is you give it right now. These ones you don't really use whenever you're doing your calculation. It's just so you know what it means. BID, TID, QID. So bi is 2. Tie, I think like try, so 3 times a day. And then QID, like quad kind of, is 4 times daily. Okay, Q, this is a blank. You put in the number of hours. H means every so many hours. So these two are really important to know the difference when you're doing your calculations. So for this one, if they're asking how many calculations in the whole day, you would just multiply the dose needed by 2. But for this one, you'd have to figure out how many doses you're giving within 24 hours. Because it would be, this is an example, Q4H, that's how they'd write it. And that would mean every 4 hours. So then you'd have to do 24 divided by 4 to figure out how many doses in one day. So that's very different from BID, TID, and QID. And then you have cap, which is capsule. So that would be like a pill, right? And then GTT, you have to know these. That's your drop, okay? They can only be whole numbers. Okay, you cannot have half a drop. That's what a lot of people get stuck on. So whenever I'd have a question with this, with drops, I would put like capital GTT next to it so I know it's drops. Next we have, these are the types of ways it can be given. So PO is per oral. That's usually going to be your capsule, right? NG is NG tube. Sub-Q is subcutaneous. IM is intramuscular. IV is intravenous. And then milliequivalence is just a type of measurement. I saw it on the HESI, but you don't. You can figure it out using what they give you in the question. So the next thing I'm going to do is talk about how to round on this exam. Every school is different, so you have to follow your school's rules. But for ours, you do it to the 10th place, and you have to round to the 10th place using the normal rule. So like, if it's 5 or more, you let it soar. This is my little mnemonic to remember. So if it's like 0.6, it would become 1, right? 4 or less, let it rest. So 4 or less, you make it less than. So if it's like 0.3, that would be 0, right? They usually won't do that. They'll do like 1.3. So then you just do 1. Okay? So those are the rounding rules. Before we start, let me give you guys some common conversions to know, okay? So you have to know these ones. 1 kilogram is 2.2 pounds. I don't know how you'll remember them, but you have to remember them because they use them a lot. These are the common ones. 1 gram is 1,000 milligrams, and then 1 milligram is, here, let me do it like this. 1 milligram is 1,000 micrograms, okay? In our school, they do use these. Then you have 30 milliliters is 1 ounce, okay? You may run into this. I don't think we had any though. 8 ounces is 1 cup, so you can use the ounces to help you. And that's all that we really had in our semester. So these were our common conversions. You have to know all of these by heart because they'll keep coming back. So now we can go ahead and go into our questions. There's about 7 different types of questions. Okay, you have intake and output. Okay, and this one, we'll go over these. These are really simple to do. You literally add up how much they took in and how much they excreted through their body and find the difference between the two. Okay, you also have like checking if they're overdosing. So these ones have several steps, but they are very doable. Okay, then you have your milliliters per hour dose questions. We'll go over those. You have to convert. I usually use dimensional analysis and it helps. And then drops, they'll give you a drop factor and you have to convert to get to a drop factor. Tablets, These ones are pretty easy to do. For these types of questions, your answer is usually either a whole number or 0.5 because you can't have less than half of a tablet. And then you'll have different types of questions. So we'll go over each of these. Okay, so let's start with a milliliters per hour question. So the question is, the order is from vancomycin 2 grams IV piggyback every 12 hours. Each dose is to be infused over 120 minutes. The vancomycin is applied in 2 grams over 250 milliliter in a 250 milliliter bag. How fast will you infuse the IV in milliliters per hour? So first, I want to write what I have ordered, what I have to give. Okay, so I have to give 2 grams every 12 hours. Okay, remember the 12 hours? We'll see if we need it, but it might not be important. Sometimes it's important, sometimes it's not. Okay, and I have to give it over 120 minutes. So to explain this situation, in the hospital they have pumps where you give your medication. You hang up the IV. It's going to be like a bag with the liquid in it, and then you set up your pump to deliver the medication. The pump can only give in hours. It cannot give in minutes. So even if you have, like say for example, you have to give 2 milligrams in 30 minutes, right? On the pump, you're going to put to infuse 4 milligrams over 1 hour, right? If it's 2 milligrams in 30 minutes, because it can only work in hour increments. So even though it's like over what's in the bag, the pump turns off on its own. So this is one thing that confused me when I was trying to do these questions, because I didn't understand how the pumps worked. So let's work through this question, okay? And then what you have may not be the same concentration as what you need. That's why you have to calculate. This one might be, because it's also 5 grams, which is what we need. Okay, so now we're trying to find, I always put what I'm trying to find right here at the beginning of my analysis. I use dimensional analysis, so I put it right at the beginning, so I know how to set it up correctly. So this is what we want to end up with. How many milliliters per hour? So we have, right here we have milliliters. So I'm going to match milliliters to milliliters right here. And then since it's with the 2 grams, it goes right under. Okay? Now, grams, you have to match the unit on the top. So right here I have 2 grams for 120 minutes. Okay? This is not important because they didn't ask how much you're going to do in a day. So for this question, that was not important information. Now, this is in minutes. We want to end up with hours. So we're going to convert it from minutes to hours. So there's 60 minutes in 1 hour. Okay? And then if you do multiply this all together, so the top, let me do the math here on the calculator. So we have 250 times 2 times 60. Okay? We get 30,000. Okay? And then on the bottom, we have 2 times 120 times 1 is 240. Okay, now we divide it. This is milliliters per hour, because see our units canceled, and we're left with milliliters in hours. Okay, let's see what it equals when you divide. 30,000 divided by 240. Okay, so we have 125 milliliters per 1 hour. So that is the amount that that's what you would put into your machine, into your pump, so that it'll give 2 grams in 120 minutes. So it would just keep pumping at this rate until the bag finishes. So your patient would get their 2 grams of medication. So this is your answer, and on our exam, we would just write 125. They didn't want us to add units. We would just have that as our answer. But that would depend on your school and what they require. You are not supposed to put like 0.0. That's not okay. Maybe your school has different rules, but in ours, they said no, because then someone could misread it and give 1,250 instead of just 125. So that's one thing you want to pay attention to, is your school's requirements. Okay, next question. Okay, so this next question asks, the physician orders normal saline, NS is normal saline, 1,000 milliliters every 8 hours. The drop factor is 20 drops per milliliter. Calculate the IV rate in milliliters per hour. Okay, so in this question, they want us to find our milliliters per hour. Okay, they told us we have to give 1,000 milliliters every 8 hours. Okay, so for this one, you want to assume that you're running over the whole 8 hours. Okay, so you don't need the drop rate at all. The 20 drops is extra information. They're trying to trick you. For milliliters per hour, all you need is milliliters and the time. So what you're going to do is take 1,000 milliliters, because we're matching it here, right, over 8 hours. That's simple. So now we solve it using our calculator. Okay, so 1,000 divided by 8 is 125 milliliters per hour. But on the exam, I would just write 125, and that would be the answer. Okay, next question. The question says, the physician orders Duflakin 300 milligrams IV piggyback every 8 hours. The drug is applied at 300 milligrams diluted in 1,000 milliliters of water, 5% water, 300 milligrams in 100 milliliters, and it's to be infused over 60 minutes. The drop factor is 20 drops per milliliter. Calculate the rate in milliliters per hour. Okay, so here they gave us a lot of information. Let's try to see what's important and what's not. So the order is for us to give 300 milligrams over 8 hours. Okay, we have, so here they said 300 milliliters here. Usually when I have like these kind of situations, I look for the final concentration, because sometimes they'll say, oh, the package says dilute the 300 milligrams in 1,000 milliliters to get a final concentration of, and it'll be like 200 milligrams in 1 liter. Okay, so you want the final concentration for what you have. So our concentration is 300 milligrams in 100 milliliters. Okay, and it's infused for 60 minutes. So, oh, and they added drop factor too. The drop factor is not important for this question because we just need milliliters over hour in our final result. So the drop factor is extra information. So what we want to do, first we have to convert. So if this would have been different, we would have had to figure out how many milliliters of this, of what we have, would we need to adjust it to make it the same. But since both of them are 300, so it's saying you have 300 milligrams in 100 milliliters, and we need 300 milligrams, so we don't need to convert. So what we would do is just take the 100 milliliters over 60 minutes, which is 1 hour, right? If you convert it, because we need hours. So then you would just do 100 milliliters in 1 hour. Okay, and that would be your answer. So this one, they put a lot of extra information, but the actual answer is much simpler. So you want to pay attention to that. Okay, now, in the next question, they said, the doctor ordered, this is a tablets question. So it says, the doctor ordered 300 milligrams Lipitor per oral every 12 hours. Lipitor is applied as 20 milligrams per scored tablet. How many tablets will you give? With tablets, the important thing to know is that a scored tablet is one that you can break in half. If it's encoded or enteric coated, those capsules cannot be crushed or opened or cut in half. So those have to be whole. But usually they don't ask specific questions like that for DNS. So they're just telling you it's scored, meaning you can have half a tablet. So here they said you need to give 30 milligrams to your patient. The hours is not important because they didn't ask for the total day. They're just asking this dose right now. And then you have 20 milligrams per tablet. You're trying to find tablets per dose. Okay, so you have 1 tablet, because we're matching the units, has 20 milligrams, but we need 30 milligrams in 1 dose. Okay, so now if we do the math, we have 30 divided by 20, okay, and that'll give us 1.5 tablets. Okay. Another way you could do this, once you get the hang of how it goes, is you can just divide this 30 by 20 right away without setting it up. But in the beginning, when I was still confused with these kind of questions, I would set it up with dimensional analysis so that I make sure I end up with the correct thing at the end. So on the exam, I would just write 1.5. And that's possible because it said it was scored tablets, so you can cut the tablet in half. Okay, so this next question says, Dilantin is ordered 5 milligrams per kilogram per day per oral, divided equally 3 times daily. Dilantin is supplied as oral liquid with a concentration of 100 milligrams per 5 milliliters. If the patient weighs 15 kilograms, how many milliliters will you administer each dose? So this one has a few steps and a few things you want to be careful with. Okay, so it says we were ordered to give 5 milligrams per kilogram per day 3 times daily. Okay, this is important. Okay, we have 100 milligrams and 5 milliliters. Okay, the weight is 15 kilograms. And we want to know milliliters per dose. Okay, so with these questions, I'd usually convert this part right away into their weight. Okay, sometimes they can make this into pounds too. So then you'd have to convert to pounds from pounds to kilograms. So you want to pay attention to that. So this is saying you give 5 milligrams for every 1 kilogram per day, right? Our patient is 15 kilograms. So I would do 15 times 5 equals 75. So we're giving him 75 milligrams in 1 day. Okay, so let's put that here instead. 75 milligrams in 1 day. Okay, but they're asking per dose, right? We have to pay attention to that. So let's start putting our equation together. So let's start with milliliters. 5 milliliters, 100 milligrams. That's what we have. Now we're converting to how much we need. So we have 75 milligrams in 1 day, but they asked per dose. So dose means right now. So that would be one of these 3 times daily, right? So that means we'd have to do in 1 day, you have 3 doses, right? Okay, so now you ended up with milliliters over dose. So these canceled, and we have milliliters and dose. Now we just multiply the top and bottom, divide, and you have your answer. So let's check how much that comes up to. So this is 375. Okay, this will be 300. 375 divided by 300 is, you do get a calculator on your exam, at least for us we did. It was a 4-function calculator. So this would be my answer. And you really want to pay attention to the 3 times daily part, because they can try to trick you with that. But for our exam, we did get to have a 4-function calculator, and our exam was on paper, so you could do your calculations on the paper. And usually, like, they'd put these questions on the regular class exams, and they'd give you paper for that too. Okay, so next we'll do a different type of question. So this one is checking if the dose is within an allowed range, so the patient isn't overdosing. So it says amoxicillin 125 milligrams per oral 3 times daily is ordered. The safe dose range is 10 to 25 milligrams per kilogram per day. The patient weight is 22 pounds. See here they put pounds. Okay, so it says we have to give. I always write these out so that I don't miss anything. Okay, milligrams. We'll see if TID is important. It might be. It says per day, so maybe it's not important, but we'll see. And then the safe dose is 10 to 25 milligrams per kilogram per day. The patient's weight is 22 pounds. We have to convert this to kilograms. And they're asking the max dose in milligrams, max milligrams per day. Okay, so for this one, the order is not important, at least for this part of the question. What is important is right here. This is your max dose. That's the highest amount possible, but it has to be for the patient, right? So I'm going to convert this into the patient's weight. So I'll just be left with milligrams per day, okay? And that's what they're asking for. So we can actually plug this in. So if we want to, so we'd have 25 milligrams over kilograms per day, right? So then here I can put his kilograms. So since our kilograms aren't converted yet, I'm going to convert my 22 pounds to kilograms so I can plug it in. Okay, so if you remember, I said there's 2.2 kilograms in 1 pound. Okay, I remember this because kilograms are always less than pounds, right? So you have to divide by 2 to get the amount of kilograms. So divide by 2.2, okay? And you get 10. So they're 10 kilograms. So let's plug that in to our equation. Okay, 10 kilograms per day, right? Okay, so that's 250 allowed milligrams per day. Okay, so the maximum allowed for this patient is 250 milligrams in 1 day. Now the second part of the question asks, is the physician's order within the safe dose range? Yes or no? So now we have to add to this. Okay, I'm going to we can keep what we have. Okay, so now let's see. We have to figure out. So they said his dose that he's ordering is 125 milligrams 3 times daily, but what we have is 250 milligrams in 1 day. So you could either multiply this one by 3, because it's 3 times daily, and compare to the allowed, or you can divide 250 by 3 and see if this one is less or the same or more. If it's more, then he's overdosing the patient. So I'm just going to take 250 milligrams divided by 3 and see how much it comes up to. Okay, so it came up to 83.3. In our school they said only round to the 10th place, so I'm only going to round to the 10th place. And they said if it's 5 or more, you have to round up. If it's 4 or less, you round it down. So this one was 8.33 continuing, so since it's 3, I rounded it to just 3, because it's less than 4. Okay, so the amount the physician ordered is 125, and that is not a safe dose for the patient. Okay, and that's the answer for that question. So no, his dose was not safe for the patient. Okay, so the next one we're going to do is an intake and output question. And these ones you're calculating the amount of fluid the patient received and the amount of fluid the patient lost, the difference between the two. So intake is anything that goes into the patient. So that could be drink, that could be broths, that could be IVs, because in IVs you have liquid going in. For output, it's anything that came out of the patient. So that could be drainage, it could be urine, it could be, if they had diarrhea, that would count too. So and urine is also part of output. For intake and output, you have to convert everything to milliliters. So remember, there's 30 milliliters in 1 ounce. Okay, they can give you stuff in ounces and you have to convert it to milliliters before you can calculate. So the question says, a nurse is receiving the 24-hour intake and output for a patient. In the past 24 hours, the patient has consumed, so that means intake. So I usually separate into intake and output. And then I put whatever goes under it there. So for intake, they had 10 ounces of broth, 8 ounces of juice, 12 ounces of water. Okay, they had 2 IV medications, 100 milliliters each. So I do 100 milliliters times 2, so I remember. And then they also received 20 milliliters per hour for 6 hours. Okay, so that's all for intake. For output, it says the patient voided 3 times. Void means to urinate. So you have 100 milliliters the first time, 150 milliliters, and 350 milliliters. And then the JP drain, the output, see they put output, from the JP drain was 150 milliliters. A JP drain is drainage from a wound usually, so that would also count as output. And that's all for their output. Okay, so on this side we have to convert these ones 2 ounces, so we multiply them by we have to convert them to milliliters. So we multiply them by 30, so we have 300, right? We have, let me check, 240, and we have 360, okay? Then we have also 100 times 2, because they had 2 IVs, so that's 200. There are all milliliters. And then 20 times 6, so 120 milliliters. Now we add all of these up, okay, to get our total intake. So we have 300 plus 240 plus 360 plus 200 plus 120. So we have 1,220 milliliters of intake. Now we just add up our output. So we have 100 plus 150 plus 350 plus 150, and we have 750. So now we just subtract these two, okay, to get our difference. So we have 470 intake and output for the 24-hour period. So that would be all I would write. Okay, so now we're going to do a drops question. So it says the order is for ANSEF, 1 gram IV piggyback infused over 1 hour every 8 hours. The ANSEF is supplied in 1 gram in a 100 milliliter bag. The drop factor is 20 drops per milliliter. How many drops per minute will you deliver? So first I'm going to put what I have to give, or what was ordered. Okay, so we had an order, 1 gram, okay, over 8 hours. Over 1 hour every 8 hours. Here, every 8 hours is not important. And then we have 1 gram in 100 milliliters. So here they're nice, they made the values match, otherwise you would have had to convert between the two. Okay, the drop factor is, so these ones you have to be careful because it says drop and you can only have a whole number as drops. Okay, so this is your drop factor. So they want to find how many drops per minute will you give. Okay, so for these questions on the exam, I actually wrote out in big bold, I put GTT like this, so that I knew it would have to be a whole number, so I wouldn't miss it. Okay, so on my exam, I did get 100 the first time, so I did a lot of practice, and it all helped. So the first thing we're going to do is match our units to units. So we have 20 drops for 1 milliliter, okay? And then we have 100 milliliters for 1 gram, okay? And we're supposed to give 1 gram for 1 hour, okay? So now if we do this all together, and that's not it because we have hours, right? We're supposed to end with minutes. So we have to convert from 1 hour into 60 minutes, okay? So now if we do all the top and divide it by the bottom, you'll get your final result. So we do 20 times 100, okay? I use the calculator just to make sure. You can never be sure in nursing school. Okay, and then here it's all 1 times 1 times 1 times 60, so we just put 60 at the end. Okay, so 2,000 divided by 60, it should come out to a whole number. Usually they do. No, this one did not come out to a whole number. So this came out to 33.33, repeating. Okay, remember it's drops. You can only have drops in whole numbers. So you have to round it. So it's less than 4, so it would just be 33 drops. That's it. Okay, if it was 33.5, you'd make it 34. Okay, sorry about my finger. So on the exam, I would just write 33. Okay. Okay, now we'll go to the next question. Okay, so this is the last question I'm going to go over, and it's the last type of question that you can possibly see. So this is reading labels. So with labels, they're usually gonna, they'll be like your usual questions, like the how much will you give to the patient? But here you want to pay attention to the label, like what the label says. So the question says, your order is Tylenol 650 milligrams per oral every 6 hours, PRN for pain, so as needed for pain. How many capsules will the patient receive per dose? So on the label it says you have 325 milligrams, regular strength Tylenol, okay? So pain reliever, fever reducer, acetaminophen. Okay, so no, acetaminophen is the generic name, okay? Know that that's the generic name. And Tylenol, the big one, is your trade name, okay? The trade names can be different, but generic name stays the same, okay? There's 150 capsules in the bottle. Okay, so for government use, okay. So that's all it says on here. The main thing we need is the amount per capsule, and that's 325 milligrams. So we're supposed to give 650 milligrams per capsule, okay? And this would be per dose, okay? And then we have 325 milligrams in one capsule, okay? So we're going to set up, here, let's fill this in. We need capsules per dose. Capsule, it's not writing anymore. Capsule per dose. Okay, so we have one capsule has 325 milligrams, and we need 650 milligrams for one dose. Okay, so we multiply the top, 650, divided by 325, and we get our answer. So let's see what that equals. 650 divided by 325 is 2. Nice whole number, so 2 capsules. Okay, so know that the small one is usually your trade name. And the big one that takes up all the space is your trade name. I hope I didn't mix that up. The little one is your generic, the big one is your trade name, okay? Usually they put the generic in like parentheses or like right above in smaller letters, okay? And then also know, sometimes they'll separate like the amount per dose by the type of injection you're giving, or like the mode that you're giving it through. So you have to pay attention, is it per oral, is it IM, IV, because sometimes that makes a difference, okay? So we can try doing another one. Let me look here. Okay, the question is, you have an order for Tagamet 400 milligrams IM every 4 hours for nausea. How many milliliters will you administer per dose? Okay, so it says you have 300 milligrams, the label says 300 milligrams and 2 milliliters, Tagamet, and then it says cimetine CL injection. So cimetidine is your generic name, okay? So it says in the small print, each 2 milliliters contains an aqueous solution equivalent to cimetidine 300 milligrams, phenol 10 milligrams. For IM injection, dilute for slow IV use. Okay, so here they only gave one dosage. So that would be you have 300 milligrams and 2 milliliters. So that's what you're going to use to help you figure out how much you're administering. So we have to give 400 milligrams. Okay, that's what we have to give, 400 milligrams. And we have 300 milligrams in 2 milliliters, okay? So we want to know how many milliliters per dose. Okay, so we do 2 milliliters, 300 milligrams. There's other ways of doing these, but this is the most foolproof way so that you don't miss any. Okay, per dose. That's how much. So we have 800 divided by 300. Okay, let's see how much that is. 800 divided by 300 is 2.66 repeating. So we'd round that to 2.7 milliliters per dose. Okay, so that's how much you'd give. You also want to know how to tell the type of medication it is, right? So usually it'll say, this one says injection, right? Some of them might say, it's an aqueous solution or something, right? So you want to be able to read these labels and understand what they say. And then, so now for general tips, that's all the types of questions that you can see, like one example for each of them. I went through the important things to know for each of them. I would say definitely practice a lot of questions. The more practice you do, the better you'll get. And I'm going to share a link to a website that has different practice, like lots of practice questions for each type of question. And it has explanations too. This is what I used before my semester started, just to practice. And then sometimes when the semester starts, your professors will give you practice questions too, so make sure to do those. And of course, there's other methods to do these questions, but I found that dimensional analysis was the most foolproof way of doing it. As you get used to them, some of them you don't have to put it in dimensional analysis. Like the milliliters per hour, when they give you milliliters and hours, when you get used to it, you just kind of divide milliliters by hours. Or if you have the capsule, you might just divide the amount you have by the amount you need and get your answer. But I would definitely say practice. And I hope you made it this far, because there was a lot of stuff I went over. But I hope this helped. Please subscribe and leave a comment. I hope you get 100 on your first try. Make sure to pay attention to those tricky little things and pay attention to what's important information and what's extra information. Okay, thank you.